So we started with geometry basics. It's just a whole bunch of notes. So you're just gonna take your notes and be going down the line with it, right? So first thing is we starting off with is a point. And a point, and you don't have to write it down word for word, but just get the point. That a point is a location in space or on a surface. It is so tiny that it has no position. No, that it has position, but it has no size. Yeah, so you have no dimensions. You can't have how big a point is. And let me know if I'm going too fast, if I need to slow down, right? Next we have a line. Now a line extends infinitely in both sides, and you can see that we have arrows showing that, right? A line has no breadth or thickness. It has length, but it doesn't have thickness. Yeah, so this one have no size at all. But then when we connect 2 points, so we have a point with no size, and if we connect 2 points together, they form a line. And they form a line segment especially. So a line is when they go in arrows infinity in both directions. A line segment is when you have a piece of a line between 2 points, right? Everybody cool so far? All right, nice. A ray is when you have a point, and out of the point you have a line and an arrow at the end showing that the line extends. So this point where the line is coming from is called the origin of the ray. So you can think about a ray of light coming from the sun. The sun would be the origin, and the arrow would be the direction in which it is going, right? So we have a point. If you take 2 points, you could draw a line, and if we take 2 lines and join them at a point, we will get an angle. We have a line and another line, and they're meeting at a point, and this distance here, what is an angle exactly? We can't really call it a distance, right? Is when 2 lines meet at a point, they form an angle. The size of an angle is measured in degrees, and it is the amount of turn. So if I was to take this line and turn it like this, you see the angle gets smaller or the angle gets larger, right? So we had a point, we formed a line, now we take 2 lines at a point and we formed an angle, right? Now at the end of the day, it has many ways that we could write an angle. So this is the angle over here, and of course this is measured in degrees, right? And it have 3 ways that you will see an angle is being written. This here, the first way is this angle is the angle at the point B. Yeah, so one way to write an angle is to have B and then this sign on top there to show that it's the angle at the point B, right? Another way to say the angle at the point B is this one, right? Now it looks like a less than sign, but a less than sign is this, right? The angle sign has a straight one like that at the bottom, right? So so just be careful. So you will see the angle B. Oops, come on, man. Yeah, the angle B looking like this, right? Or sometimes they could spell out the entire triangle A, B, C. So you have the triangle, well, the lines A, B, C, and then you could show the angle at B. So this here are the 3 ways that you will probably see angles, and you should probably check out this link as well. This link have some cool stuff for you guys to play with. Everybody cool with what's an angle, right? I know this is real baby stuff. Ariel, you okay with this?
Yes.
All right, nice. Now, we say we measure an angle in degrees, and how do we do that? We do that using a protractor, right? So we are using a protractor. A protractor is this device here. We use it to measure angles. So you could see here that as the angle increases, I could measure, you know, how much that increases. So we could see here that this is 0 degrees, and I come up 10 degrees, 20 degrees, 30 degrees, 40, 50, 60, 80, 90 degrees, and you can see what 90 degrees does look like. And then we can keep going, and you can see there that a straight line has an angle of 180 degrees. So you can see the angle of 180 degrees there. Everybody understands how to measure angles?
Yes, sir.
All right, thank you very much. All right, and of course, when we are talking about angles, we're talking about turn, and if we're talking about turn, we're talking about circles, and we have a revolution. So when I bring the angle a full 180 degrees, I could carry it another 180 degrees to give us 360 around the circle, and that is called a revolution. All of these things are points that are required by you to know by CSEC. You are required to know by CSEC, right? We have two different types of rotations, and you can see it here by the scrappy arrows that I've drawn. We have the clockwise rotation, and we have the anti-clockwise rotation, right? So you can just make a note of these things in your book under the topic of geometry. Remember, you'll need a cheat sheet for geometry as well. Everybody cool with clockwise and anti-clockwise rotations? Yeah? Yes, sir. Now, we see in here that we are going to talk about the types of angles. So we started with a point, then we talked about a line, then we talked about when two lines come together at a point, they just form an angle. We saw how to measure angles. Now we're going to talk about the types of angles. And we see here that we have three first types of angles here. We have the right angle, which is 90 degrees. And you can just make a sketch real quick, right? We have the straight angle, which is an angle of 180 degrees, right? So that is when you extend the angle all the way to a straight line. That is 180 degrees. It's called a straight angle. So when the CSEC question asks you, hey, what is a straight angle? You are supposed to know what a straight angle is. So we have a right angle, a straight angle. Next we have an acute angle. So the acute angle is any angle that is less than 90 degrees. Yeah, so we could see what an acute angle looks like, right? All of this is the 30 degree here, but we could raise it straight up to 89.9 degrees, right? And that all of that is acute. Once it's less than 90 degrees, it's an acute angle. Everybody understand what's an acute angle? The obtuse angle is more than 90 degrees. So if it is that 90 degrees will cut about here, once it is more than 90 degrees, but it's not a straight angle, once it's more than 90, it is obtuse. So between 90 degrees and 180 degrees, right, this area here is where the angle is obtuse. Everybody cool with the obtuse angle?
Yes, sir.
Right, thank you. And then we have the reflex angle, and the reflex angle is greater than 180 degrees. Yeah, so we can see here. Now, how do we measure a reflex angle? We can see here that this angle here, this is 180 degrees straight. So if we start here, acute, 90 degrees, obtuse, 180 degrees, and reflex, more than 180. So what I could do is I could take my protractor and measure that as 180 degrees, and then add on that amount. Talking about types of angles, we see in here the right angle, the straight angle, the acute angle. We have here the obtuse angle, more than 90 degrees, right? We have here the reflex angle, more than 180 degrees. Now we're going again, things starting to get heavy now. We're talking about complementary angles. This is a word, these two words here are words you will see often in CSEC. So please know what they mean. Complementary angles are angles that add up to 90 degrees. So you see A and B. And if I take A plus B, I get 90 degrees. So that means that A and B are complementary angles. Supplementary angles are angles that add up to 180 degrees. So you see C and D, if I add them and I get 180, they are supplementary. So everybody understands the difference between complementary angles and supplementary angles.
Yes, sir.
Alright, I hope so. Please slow me down or stop me if you think I'm going too fast. Things are about to get heavy, right? We're talking about adjacent angles, and an adjacent angle is just two angles that share the same side. So you see this side here, right? So the two of these, angle A have this side and angle B have the same side. So the two of them sharing the same side, they are adjacent angles. Yeah, I hope everybody is okay. Moving on. Now we're getting quite heavy, right? We're talking about if I have like an X, two lines in an X coming to a point, right? What they do is they form vertically opposite angles, right? So if I have any X, right? Any X at all, it does not matter, yeah? Then the angles that are vertically opposite, so this angle here and this angle here, they will be equal. This angle here and this angle here will also be equal. So we can see here, if the angle A is 60 degrees, well then the angle, this angle on this side is also going to be 60 degrees, right? Vertically opposite angles are equal, yeah? And the next thing, just the same as vertically opposite angles, you can see we still have the X, we have the point, so we see that A and C are vertically opposite, which means that A is equal to C, yeah? We see that B and D are vertically opposite, so B is equal to D, right? But another thing is that all of these angles are around a point. So if I add up all of these angles here, I am supposed to get 360 degrees. So these are two things when it comes to angles around a point. Number one, an angle, number two, but anyways, an angle at a point, right? The angles at a point all add up, or angles around the point add up to 360 degrees. And angles around the point, the vertically opposite ones, are always equal. Everybody okay? Or their brains starting to get heavier? No? Alright, cool. So just a recap, just to see what we're looking at here. Types of angles: right angle, straight angle, acute, obtuse, reflex, complementary, supplementary, adjacent angles having the same sides. We have vertically opposite angles and angles at a point. So by the way, we had types of angles. Now you see we're getting into the properties of angles, eh? Right? So these were the types of angles: straight, right, acute, obtuse, reflex, complementary, supplementary. Those are your types of angles, right? Now we have the properties of angles, and I guess complementary and supplementary should probably be under properties as well, right? So in the properties of angles, we have adjacent angles, vertically opposite angles, angles at a point, and I'm just asking if everybody okay, because it's about to get heavy. Everybody cool? Shazay, you remember all this stuff? You know all this stuff?
Yes.
Alright, well let me see how much you really know, right? We're continuing with the properties of angles, and we're talking about parallel lines, right? Parallel lines never meet. They are always the same distance apart. They never intersect from one, they never intersect. They always form the same angle with any traversal, right? A transversal is a line that cuts two parallel lines. So if I have two parallel lines like this, and I just draw any line like that, Yeah? It doesn't matter. This line is called a transversal. Transversal. It cuts two parallel lines. And what they're saying here is that when we have two parallel lines and we draw a transversal, the angles are equal. So this angle here that the line making with this bottom parallel is the same as this angle here that the line making with the top parallel, because the two of them parallel. So does that make sense to y'all? That because the two lines are parallel, this angle here will be equal to this one. Does that make sense?
Yes, sir.
Right? Does it make sense that this angle here is equal to this one? Does that make sense? Do you all agree that this angle here is the same as this angle here? Do you all agree with that?
Yeah.
Because if this is the same, if this and this is equal, right? Remember, these two are angles on a straight line. They form 180 degrees, right? Yeah. So therefore, these two here and here will also be equal. Right? So are we all in agreement with that?
Yeah.
And imagine this is our angle here, but guess what? This angle is vertically opposite to this one. So these two will be equal. Does that make sense?
Yeah.
So that means that this angle is equal to this angle over here. Does that make sense? And this one is equal to this one.
Yes, sir.
Right?
Yeah.
And this one is also equal to this one because vertically opposite, right? So therefore these two will also be equal. Yeah? Right? So we see here that when we have parallel lines and we drop a transversal, all kind of cool angle things just happen. Yeah? So let's check out the properties of angles when it comes to more transversal parallel line businesses, right? So and all of these seem like different laws and different rules, but they're actually really, really easy to figure out. So the first rule is this, right? Interior angle. So you could probably head up properties of angles and then head up parallel lines. Properties of angles, parallel lines, right? And the first one is interior angles, and interior angles always add up to 180 degrees. So look at the interior angles here and here. Yeah. So if I add these two, so if I had these parallel lines and I drop a transversal like that, these two interior angles, this one and this one, will always add up to 180 degrees. Everybody okay with this?
Yes, sir.
You all think you could identify interior angles? Yeah? Do you all think you could look at it and identify, like, are these two here interior angles? Yes, the answer is yes, they are interior angles, right? So imagine, how do you spot interior if I have these two and the transversal passing here? Look at this rectangle that's being formed here. And these two angles are inside the rectangle. Yeah? So that these two are interior, the inside, right? And then look at the other side. We have a next rectangle over here, and both of them are inside the rectangle, isn't it? So they are interior. They're next to each other. They're not adjacent, but they're next to each other. Yeah? Everybody okay with interior angles? Ariel, are you fuzzy yet?
Nah, good.
You're good? Alright, we go in it. Go and get heavy, you know. We're in the middle of the heaviness right now. Tell me when your brain starts to hurt, right? Can we move on from interior angles? Yes? Right. So we have corresponding angles now, right? Corresponding angles are always equal. And the corresponding angles are just what I showed you before. You see, when you have two parallel lines and a transversal, cut it like that. Right? That means that it's cutting it at this angle, but the lines are parallel, so that means that it's cutting it at this angle as well. Everybody agree with this, right? Does everybody agree with this?
Yes, sir.
Right, Ariel, you okay?
Yes, sir.
Right? So if this transversal is cutting these two parallel lines, that means that this angle here is the same as this angle here. Does that make sense? Because this transversal will be cutting the lines in the same way. So these two angles are corresponding. So if we call this angle A and we call this angle B, A equals B, right? Corresponding angles are always equal, right? So are there any other angles that are corresponding here? Can't I say that this angle here is the same as this angle here? Can I say that? Yeah, Ariel, do you understand that?
Yes, sir.
So that means that these two angles are corresponding as well. What about this angle here being the same as this angle here? See where I'm going with this? So these two angles are corresponding as well. What about this angle here being the same as this angle here? See where I'm getting at? Yeah?
Yep.
Right. Shazay, you okay?
Yes, sir.
Caitlin, you alright?
Yeah.
Anybody confused? Right. Now at the end of the day, they calling all of these things different things like interior angles and correspondent angles, but really and truly, it's just angles at a point, right? At the end of the day, if you have this angle here, obviously it's going to be the same as this one, right? And because this vertically opposite to this, that means that these two are equal, and that means that this will correspond with this one. So that is equal, and these two are vertically opposite as well. Yeah? So it's really just the vertically opposite rule I'm looking at here, right? And these two are vertically opposite. Yeah? So these two will add up to form 180 degrees. These two will add up to form 180 degrees. So we have angles around a point as well, right? So all of the things we learned before are still applying here. The reason why I'm saying this is because if for some reason in the exam you cannot remember what a corresponding angle or interior angle is, just know that that vertically opposite rule. The other rules will help you to figure it out, right? So everybody understands corresponding angles. So we have interior angles, we have corresponding angles, and next we have alternating angles, right? And what we see in here, alternating angles. So if we have, right, alternating angles are found on the opposite sides of the transversal, right? So alternate angles are, if I was to draw a Z here like this, you all seen the Z, right? Okay. I have this angle here, the inside of this Z here, and then on the opposite side of the transversal, on this side here, I have another angle, and I'll call this angle B. These are alternating angles, and alternating angles are equal. Yeah? Right? Let me ask you something. Angle C, angle D. Are these alternating angles? On here, yes, they are. They are on opposite sides of the transversal. So we have CD. They are also alternating, right? Now, at the end of the day, it makes sense that if this is A and this is equal to B, so if these two are equal, then whatever is left to form the straight line, this is a straight line here. So obviously A plus C gonna give me 180 degrees, right? So if A is the same as B, whatever is left here will be equal to whatever is left over here. Yeah? So know how to see your alternating angles. Sometimes it's easy to see it inside of a Z like this, right? But sometimes it might not be as easy, especially in this case here with the C and the D. But once they are on opposite sides of the transversal, they are alternate angles. Everybody okay with alternate angles? Though we talked about a point, a line segment, a ray, angles, when they meet at a point, how to measure angles in degrees, a revolution, rotations, types of angles, the right angle, straight, acute, obtuse and reflex angles, complementary angles, supplementary angles, adjacent angles, vertically opposite angles, angles at a point, parallel lines, and we talk about transversals now, so the interior angles, corresponding angles, and alternate angles. Just one more time, the types of angles are right, straight, acute, obtuse, reflex. The properties of angles are complementary, supplementary, adjacent, vertically opposite, angle at a point, and then the parallel, transversal properties are interior, corresponding, and alternate. How all you feel? Are your brain ready to explode yet? So name the relationship. So these are the kind of questions you will get where they will show you an angle. So these two here are supplementary because they're on a straight line. These two here are adjacent. Complementary, supplementary, vertically opposite, or adjacent. That is what you have to identify, right? Find the measure of angle B. Of course, you're not going to measure, you're going to work it out. So these two angles are supplementary, so 180 minus 50 will give you B in this case. These two angles are vertically opposite, so they equal, so B is equal to 43 degrees. Right? These are angles around a point, so they add up to 360, so you can find B from there. And these are complementary angles, they add up to 90, you could find B. Right? And then you have some nice little one where algebra is involved. Right? So you have to find X. So if you look at number 21 here, I don't know if you're seeing this properly though, but number 21 here, we have 2 plus 3x being vertically opposite to the 62 degrees here. So you know that they equal, so from there you should be able to find X. And of course we have our parallel lines questions, so you have to know which is which and who is who, right? And right, so yes, and I didn't put any answers here, so we'll talk about that. So these are what some of the more CSEC like questions will be. Determine the size of the following marked angles, give reasons for your answers. So you see this angle here, P and 64 degrees. Well, they're on a straight line, so they are supplementary. You have to give reasons, so you have to state because they are supplementary. Right? You have to state over here angles around a vertical angles and angles around a point, you know, and that kind of thing. Right? So we have just some questions here, and it could get quite complicated sometimes. You see two parallel lines when they have arrows like this. You see when they have arrows, that is the symbol for them being parallel. You all seeing that? Yeah? You see these arrows are pointing at here?
Yeah.
Right? You seeing these arrows are pointing at here? Yeah? Now what about this one and this one? Yeah? And this one and this one? Right, so they are parallel, so it can get quite tricky. So this is your assignment for Saturday. Yeah? You have 2 of them. Right? So by the time you've done these 2 PDFs, right, you should be, and this one is not much questions, neither of them is not much questions. But by the time you finish these 2 PDFs, you would have known for sure you're going to know all of your angles stuffs, right? Right. So we spoke about the point, and then we have the line and the line segment, right, between 2 points. And then when you connect 2 lines at a point, you form an angle. And we spoke about all of the types of angles that there are, yeah, and all kind of thing. But now there's just 2 lines with 1 angle. If I add 1 other line, right, and this is why the number 3, the Holy Trinity, is such a holy number, because you cannot form a shape with less than 3 lines. So if I have 2 lines, I could never form a shape. I need 3 lines to form this reality that we live in. Yeah? To form all of the shapes that you see around you, you need 3 lines and 3 angles, right? So when we have a shape now, and now we can add more lines and more angles, right? And you see it's all straight lines there. We are talking about curves and thing yet, right? So when we have straight line shapes like this, we call these polygons. So the next heading we're going to be talking about are polygons. What is a polygon? A polygon is a closed plane figure with straight sides. Right? A closed plane figure with straight sides. We have regular polygons and irregular polygons. Right? So we will see a regular polygon, and just mark these 2 types, regular and irregular. Right? It closed is a plane figure, it has straight sides. A regular polygon has all the same lengths, so each side has the same length. That is a regular polygon. An irregular polygon, each side does not have the same length. They have different lengths, right? So we're going on to polygons now, and these are the types of polygons that you are going to have to know. And we are actually in the next class, we are going to be going into the details of each of these in the next class, right? But not today. So we have triangles, and you can see triangles have 3 sides, right? And we have different types of triangles that we will talk about just now. So the types of polygons, we have the 3-sided figures, which are called the triangles. We have 4-sided figures, which are called the quadrilaterals, right? And then we have everything else: the pentagon, the hexagon, octagon, so on and so forth. For CSEC, you are required to know all of these, and you're required to know the basics of, they might give you a pentagon, but definitely all of these, right? So now we're gonna get into a little more detail as to the polygons. So you can see the 3-sided figures, we have triangles, and 4-sided figures. 4-sided figures, quadrilaterals, we have 2 types of quadrilaterals, right? We have parallelograms. Parallelograms mean obviously that the opposite sides are parallel. So I'll put the little arrows here. These opposite sides are parallel. So you can tell these opposite sides are parallel. We call them parallelograms. These opposite sides are parallel. We call them parallelograms, right? Trapezoids. Trapezoids do not have parallel lines. So these 2 lines might be parallel, but these 2 lines are not. Yeah? These 2 lines might be parallel, but these 2 lines are not. Right? So those are your trapezoids. So we have quadrilaterals, and the 2 types of quadrilaterals are parallelograms and trapezoids. And parallelograms have all parallel sides. Trapezoids do not. So now we're going to start to talk a little bit more about triangles. You can check out this link over here. That link is pretty good. So a little bit more about triangles now. And these are, and let me just erase all of this junk so that I can right? Now these are all of the types of triangles that you have to know, right? And you know we don't have much time. You don't have no getting back to this topic. Like statistics, we're not going to go back to statistics, you know, we done. So you better make sure you know statistics for when we come back to exam past paper time, you know. So please, after this class, I expect you all to know all of this, yeah? So the types of triangles, we have these types of triangles, we categorize them by the sides or by the angles. So we have the Equilateral Triangle, where all three sides are equal. If all three sides are equal, that means all three angles will be equal. An equilateral triangle always has angles of 60 degrees because only the angle of 60 degrees can give us 360-degree angles can form an equilateral triangle. No matter how long the sides are, once the sides are equal, you will end up with 60 degrees, right? So that's an equilateral triangle. 3 equal sides, 3 equal angles, and that is 60 degrees, yeah? Now we have the Isosceles Triangle. The Isosceles Triangle have these two sides are equal, so 2 equal sides. And when you have 2 equal sides, these base angles are going to be equal as well. Yeah, so once you have these sides having the same length, then this angle, so it also has 2 equal angles. Right? And then we have the weird Scalene Triangle. Nobody likes the Scalene Triangle because it does not have any equal sides and it does not have any equal angles at all. Yeah. So we have 3 types on this side when it comes to equilateral: isosceles, scalene, and then on this side we have an acute triangle where all of the 3 angles are less than 90 degrees. Right? So you could say that this equilateral triangle is an acute angle because all of those 3 sides are less than 90 degrees. Yeah? So an equilateral can be seen as an acute triangle, right? The right triangle has 190 degrees, so a right-angled triangle, yes? And the obtuse triangle has one angle that is greater than 90 degrees. Yeah. So in terms of angle, we see that we use 90 degree as like a benchmark here. So if you're less than 90 degrees, you have an acute. If all of them are less, if you have 190 degree, you have a right angle, and if you have one that is more than 90 degrees, you have an obtuse. Does everybody understand the types of triangles? So we have quadrilaterals. On this side, we have our parallelograms. On this side, we have our trapezoids, right? So we could see here that the parallelograms have parallel sides, of course, right? What are the properties of a rectangle? And let me ask you something, right? And here's this question, and finally I'm gonna ask you something because I talk in the past hour and 10 minutes, which is always the case, right? Is a triangle, is a square a rectangle, or is a rectangle a square? What do you have to have when you have a rectangle?
2 long sides, 2 short sides.
Well, okay, yeah, 2 long sides, 2 short sides, but the opposite sides are equal length, right?
Yeah.
Opposite sides equal as 1. Number 2, 4 90-degree angles, right? Yeah. So we have 90 degrees here, right? Number 3, opposite sides parallel, right? And of course, that'll account for your 90-degree angles as well, right? But you had to have 90-degree angles because over here you could have opposite sides parallel and it's still not a rectangle. It's a parallelogram, right? So, let me ask you something. Does the square have all of these properties? Are the opposite sides of a square equal?
Yes.
Yes.
Right? Does a square have 4 90-degree angles?
Yes, sir.
Yes.
Are the opposite sides parallel?
Yes.
Right. So, a square is a rectangle. But a square has one very special property. What is that? What is the one most common special property about a square?
All sides are equal.
All sides are equivalent. All the sides are equal, right? Can we say that about a rectangle? Are all the sides equal?
No, sir.
So you could see that a square has all of the properties of a rectangle. So a square is a rectangle, but a rectangle is not a square. See that? Did I just blow your mind? No?
Yes.
Alright, nice, right? So I am glad for that. You have a rhombus here. The rhombus has opposite sides parallel and equal. Right? So it's just like a rectangle, right? So opposite sides parallel, 1. Number 2, opposite sides equal, right? Opposite angles are equal. Angles equal. So this angle is equal to this angle. Yeah? This angle is equal to this angle. Right? So look at these three here. Does a square have these properties? In a square, are the opposite sides parallel?
Yes.
Are the opposite sides equal? In a square?
Yes.
Are the opposite angles in a square equal?
Yes.
So we could see here that a square is also a rhombus. Right? So a square is a rectangle and a square is also a rhombus. Yeah? But guess what? A rhombus is not a square. Yeah? So we can see the square is a very special guy. The square is a very, very special guy. Right? And what's the difference between a rhombus and a kite? Yeah? Because they both look weird. Well, a rhombus, we have the opposite sides being parallel. Right? We're not seeing any parallel business going on in a kite. In a rhombus, the opposite sides are equal. Right? But in a kite, it's the adjacent sides. The sides that are right next to each other, that join at a point. Those adjacent sides that are joined at a point, those sides are equal. So this is equal to this. Everybody understands the difference between a rhombus and a kite?
Yes, sir.
Right? Your brain started to get overloaded yet?
Not really actually enjoying this class.
Alright, it's easy form tree stuff, right? So we have a little more details here about quadrilaterals. There's nothing new that we were talking about, but there is one thing that I did not tell you though. So let's go back to triangles, right? And this is an important property of triangles and quadrilaterals, right? No matter the triangle, all angles in a triangle add up to what? Soraya, Caitlin? Soraya, Caitlin, Shazay. 180 degrees. Every single form tree is supposed to know this. No matter the triangle. No matter the triangle. So you can see here the equilateral triangle. 60 plus 60 plus 60 gives you 180. Yeah? No matter the triangle, all of the angles inside a triangle will always add up to 180 degrees. Ariel, do you remember this from school?
Yep.
Alright, lovely. And well, since you remembered it, can you tell me what do all of the angles in a quadrilateral add up to?
Is it 360?
Yes, and you could check the square. 90 by 4 is 360. So all of the angles in every quadrilateral add up to 360 degrees. You see them 2 points? The 180 degrees for triangles and 360 degrees for quadrilaterals. Them is thing that is common CSEC. Remember them 2 things. I see a dread algebra question that them bring based on them 2 little points. And if you couldn't remember them little things, you would have never figured out the question. Yeah? Well, we will see that question, right? So we have some more stuff about quadrilaterals, and as I say, we are actually going to spend an entire class with quads and triangles and circles and stuff. So we're gonna get quite into the detail, but this here shows some nice little things like in an example in a rhombus, these 2 angles are equal, and the opposite angles are equal, right? It shows a nice thing about a kite, that when you draw diagonals from the opposite sides, you will get a 90 degree in the middle here. It have all kind of properties, all kinds. You could study these shapes for the rest of your life and keep finding different properties. Yeah. Right. Well, make a note of this one as well. The Isosceles Trapezium or the Isosceles Trapezoid, where these 2 where the 2 lines that are not parallel, because these 2 lines here are parallel, but the 2 lines that are not parallel are actually equal. And because they are equal in an isosceles trapezoid, because they are equal means that these 2 angles will be equal as well as these 2. You could think about it like an isosceles triangle, right? That's why they call it an isosceles trapezoid. We have some more properties here that we already spoke about, so we don't have to get too much into it. And that's it. Homework, design your own house. That was from a Form 3s, right? If we look here, because I'm covering some of the baby stuff, but I'm not going to cover all of the baby stuff. I have some videos with the baby stuff. The videos are not long, right? The videos, this one here is half hour, this one here is 20 minutes, this one here is 10 minutes. So it's the 3 videos together is pretty much just 1 hour, right? This first video here is on perimeter, right? This next video here is on area, and this next video here is on compound areas. So you are going to watch these 3 videos before Saturday, right? And there is another video here. This is just the Google slides that I used in the video, right? So video on compound shapes, and that is just the Google slides that I used. So whilst you're watching the video, you could follow along with it, right? So here is I have my areas of compound shapes questions, and Asishaze, you already did this, and so did Scotia. So that only leaves 1 person, yeah. Alright, well, more than 1 person if my Form 4s want to get into the fun, yeah? So, at the end of the day, you see all of this by Saturday. I'd like you guys to have all of this done, right? And there's 2 assignments. The first assignment is on angle properties, and then the second assignment is on the area of compound shapes. And as I said, I have these videos here that are talking about perimeter, area, and the area of compound shapes. So these 2 assignments for Saturday, and on Saturday we are going to start construction. So we will correct the assignments and we're going to do construction, which means you'll need your geometry set and all of this kind of thing.